Hello everyone, I'm Tiantian from Zhejiang University. I'm glad to introduce my work, MagBackdoor. Beware of your loudspeaker as a backdoor for magnetic injection tech. Nowadays, smart speakers, smart homes, smart laptop as a voice interaction platform to bridge the humans and machines. They play very important role in our daily life. Smart healthcare, smart driving. They connect our smart home devices, and they provide hands-free services, and they improve our user experience. However, these voice devices are not secure. They always face many attacks. Looking through this research on text research, you can see diverse attacks: ultrasound attack like dolphin attack, electric attack, audible noise injection. Even you can inject maliciously by using lasers. Deep into it, you can see previous attacks always target microphones directly. You use the ultrasound lights attack microphones directly. This inspires us whether a benign component can serve as a backdoor for injection attacks. Looking through the audio systems in our devices, you can see microphones and loudspeakers always close to each other. This is because, due to the need of low cost and small size, they always share the same hole and audio codec. Thus, once the microphone loudspeakers emit sound, the microphones will pick up the sound. So, why not controlling loudspeakers as a backdoor to injection voice commands? Looking through the structure of the loudspeakers, you can see the currents on the coil will induce magnetic fields. The magnetic fields will push the diaphragm to move forth and back rapidly, which will cause air vibrations that we hear sound. So, why not controlling the sound production of the loudspeaker using an external magnetic field? To expand the feasibility, we first to determine which type of magnetic field is worked, static magnetic field or dynamic magnetic field. To choose it, we conduct a simulation experiment where a loudspeaker is under the uniform magnetic field. We change the frequency and intensity of the loudspeaker and record the sound from the loudspeaker simultaneously. We find one static magnetic field on the loudspeaker. The loudspeaker cannot emit any sound, while dynamic magnetic field covers on the loudspeaker will emit cold sound. Thus, we choose the dynamic magnetic field as our aggressive signals. In real world, how about the dynamic magnetic field works on loudspeakers, microphones, loudspeaker combination? We conduct a realistic experience. In our experience, we find that the dynamic magnetic fields cannot inject commands into microphones directly. Although it cannot inject commands into microphones, it can achieve strong injection performance with the nearby loudspeakers. Another question is, what about dynamic magnetic fields? What about other electric components in our devices? Does they have an impact on our attacking results? To prove it, we also conduct another realistic experiment. In our experience, we choose iPhone 6s as our attacking. The one iPhone 6 is intact, while the other is stripped of all loudspeakers. We find that only intact iPhone 6 can record injected audio triggered by magnetic fields, while the non-speaker iPhone 6 cannot record any sound. Thus, we conclude only loudspeaker can serve as a magnetic field backdoor, while the other internal component has no impact on it. Based on our findings, we design our systems. Before introducing it, we firstly describe our threat model. Firstly, the attacker cannot install software or alter the devices. The second, the attacking process is overall automatical. Once the setup is deployed, the attacker cannot touch it. 3, the attacking setup is compact enough to be hidden in some corners, such as a power socket or under the table. This is the structure of our design system named MagBackdoor. You can see it can emit magnetic fields inside of power socket to attack the nearby smartphones. According to our theorem analysis, we find the rules to how to manipulating magnetic fields. We find the frequency and the intensity of current determines the frequency and the intensity of the sound from the loudspeakers. Thus, we design hardware circuits for aggressive current generation. Simply, it involves digital to analog circuits to decode the digital fields that you want to inject. The decoded current will be loaded on the electric magnet. Second, although you querying your current that you want, the weak amplitude cannot induce the magnetic fields. So we decide a two-stage amplification that involves in pedal modulation and current amplification. You can amplify the current without distortion, and it will not introduce new noise into it. The end of the system is a magnetic field transformation. You can see to choose a suitable electromagnet. We test the performance of MagBackdoor on the different design parameters electromagnet and to choose the suitable design parameters. Also, to prevent the sound from leaking from the devices to the users, we also have to decide several experiments to choose the suitable currents that will be loaded on the electromagnet. This is our prototype of the MagBackdoor. You can see it has a small cost, small size, and its operation is automatical, and it can be controlled via Bluetooth. And compact size allows it to be hidden in a conspicuous corner, such as power socket or under the table. We evaluated among all kinds of devices. We set 3 metrics to evaluate. Injection success rate is used to assess the injection rate of the injection text. PSQ is used to assess the quality of the injected audio triggered by MagBackdoor. STI is assessed to assess the intelligibility of the injected audio triggered by MagBackdoor. This is overall performance. You can see MagBackdoor achieves the strongly injection performance among all kinds of devices. The high PSQ and STI demonstrate that it has the injected audio has a strongly powerful quality and injectability, just like human sound. We also evaluate across the different conditions. You can see it has a strongly robustness, regardless no different noise, different conclusion, and apps running in the devices. We also evaluate its positions that on the effective of the MagBackdoor. Although it has a limited attacking range, but compact size allows it to be hidden in a power socket, so it can achieve strongly performance with a disguise of power socket. In countermeasure, we also evaluate sound blocking and interrupting shielding for defenses against our backdoor. According to our results, these methods can suppress partly our attacking ability. In the future, we try to improve our attacking ability of MagBackdoor. Except for attacking loudspeakers, MagBackdoor also magnetic attack can also attack dynamic microphones and transformers. They are also based on the mechanism. In conclusion, MagBackdoor is the first magnetic threat on voice devices. We also designed a prototype to deploy it. Thank you for listening.
Any questions from the audience? Okay, well, maybe we're thinking, I will have the first question. So when I see the commands you are trying to inject by the magnetics.
Yeah.
I can see that they are mostly like contains 2 or 3 words. The longest
Yes.
is the 6th word. So I guess did you evaluate the impact of the length of the commands and the injection success rate?
Good question. Thank you, Chair. MagBackdoor can inject any long audios with regardless type. We choose the 3 or 4 phrases because they are commands that we frequently used. So long words sentences is also can be injected. It's not impacted. Yes.
Okay, I see. Okay, I also have a question. So your injection, as we can see, the longest distance may be like tens of centimeters. The longest distance of the injection.
Yes. So because our attacking distance is very short, this is because our power is not enough. It's about 12 probe around. So you can extend the attacking distance by using many areas electromagnetic or high power currents. Yeah, but it cannot be hidden in a power socket for stealthy. I make a balance. Yeah.
Does it require kind of a clear path between the signal transmitter and the smartphone? If it is blocked,
my block can penetrate some classical words. It has a high penetration ability. Yes.
Okay, I see. Let's thank the speaker again.